This video is an introduction to debt sculpting. So last week I asked people in my LinkedIn community, I asked them whether they want me to explain about any of the below topics. So I gave them up the options of the project life cover ratio, debt sculpting, Professor Edward Bodmer's parallel model, and the last one was concessional funding. So 52 people voted and 40% were for the debt sculpting, and then the next one is Professor Edward Bodmer's parallel model. And I should confess to you that even if I start talking about the debt sculpting, which is what I'm going to do today, eventually this road is going to end in Edward Bodmer's parallel model, because as we add more complexity in the financial models, then it will be very difficult to kind of do this sculpting, this automatic sculpting of the debt without having the parallel model included in your models. I have reviewed models that people, they have tried different ways of doing it, but it's just extremely difficult, and it's just going to make our financial model so inefficient. But if we want to have this automatic sculpting together with the copy and paste macros. However, this is not what I want to discuss with you today. In this session, I'm going to take this opportunity to just talk to you about the concepts and just talk to you about this concept of curved sculpting. You know, that's the main point of this video, because the other sculpting methods, most of you are familiar and most of you have heard, but the concept of curved sculpting might be new to you. So that's what I'm going to do. I'm going to take you through an Excel model, and we're going to see these different sculpted repayment profile and their impact on the equity IRR. So I'm showing you now a financial model, and the disclaimer is that in this model, I am assuming that debt is already sized based on the maximum gearing. So it's a very important point, because we are not using the cash flow to size the debt, okay? So this is out of the way. So that's why I say that it's kind of a more simplified version of what we normally do, because one of the options to size the debt is the cash flow available, that you look at the future cash flow and you see what is the debt service capabilities of a project based on that, and you size your debt based on that. But we're going to just say that this is out of the way, and debt is only sized based on the maximum gearing. Okay, this is just for simplification for this case. Now, let's go through the input sheet. So I'm going to just take you, these are the technical parameters. We're going to just focus on the financing assumption. So you see that we have one only senior debt tranche, and it has a tenor of 10 years with an interest rate of 4%. Some fees are payable during construction. And in terms of the principal repayment, which is the main topic for today, we have provided three options in this model. Option one is the annuity payment, which is also automatic. So if the switch is set to annuity, the model is just going to find the principal repayment profile that would enable us to have the same interest and principal in each repayment dates. Then we have what we call automatic sculpting, that we're going to talk about it as well. I'm going to show you what I mean by this automatic sculpting. And there is also a manual one. Usually what I do across all my models, I include this manual sculpting as well. Why is that? Because eventually, remember, once you sign your loan agreement with your lender, these percentages, which are the percentage repayment profile, are going to be hard-coded in your loan agreement as the repayment schedule. And so you take those percentages, which at the first place, they came from the financial model. They go to the loan agreement. Then once they are there, hard-coded in the loan agreement, you take it from there and hard-code it also in the financial model. That's why you should always allow this option in your models, just thinking ahead of time for the time where you need to fix the repayment profile, because the lenders, they already have their board approval. So this repayment profile, a certain repayment profile, will be fixed in the financial model, and you have no more room to play with it. So that's an option that you want to also include. But today we're going to talk about this manual sculpting. Okay, so all of these I have already modeled them. You see I have all these options. This is my senior debt. I am modeling the annuity payments. Then I have the automatic sculpting, which is in another sheet. I just wanted to make it easier for you to see. That's why I put it in another sheet, and we're going to go through it now. And then we have this manual sculpting, and we have this switch, which we presented here. We can also bring it, put it wherever we want to. So we're going to also put the switch maybe here, and we can go through this different repayment profile with the help of this switch. Okay, so let's see how the model looks like when we have an annuity repayment. So as you can see here, this chart is very useful. I usually add it across all my models. It is just showing the cash flow available for debt service versus your debt service, and the ratios all within the same graphic. So you see here that in the annuity payment, we have, first of all, in terms of the cash flow, you see that you have some sort of seasonality in your in the cash flow, in the revenue. So there is something happening which is causing some seasonality in the cash flow. You see that you don't have kind of a straight line for your cash flow available for debt service, but it's kind of like a zigzag. Okay, this is sometimes called seasonality. So in the annuity payment, you see that there is a problem here, because you start with 1.01 and then it goes up and down, but this 1.01 is going to cause a problem. Why? Because when you come to your input sheet, you see that the minimum requirement by lenders is 1.3. So this is a threshold that you need to always compare your minimum with, and that's why you see that you have this master error check, which is showing you that the let me just make it bigger, that the minimum is not met. You see the minimum periodic Dscr is not met, and that is why. So we need to just remedy this. We can remedy this. We can actually easily remedy this issue. Why? Because when you look at your average Dscr, it is 1.49. So you have room to sculpt it, right? You should not be shy away, and you can actually sculpt it. So I come to this sheet and I'm going to show you, first of all, the only thing I did, I listed as a checks all the requirements that I have from my lender. So for example, as we said, lenders, they said I want a minimum periodic Dscr of 1.3. I compare it with what I have today in the model is 1.01. So the check is going to tell me that something is wrong. The other requirement by lenders is the LLCR. Most of the time, and I have different video about it, I recommend you to go and check it out. LLCR as well is one of the requirements, and usually they impose a certain minimum. So you also need to check that minimum in your model with the threshold that the lenders provided to you and put a check. So I also put it in front of me when I'm doing my sculpting exercise. And the last thing that I look at, it's the weighted average loan life, okay? And the lenders, they tell you that when you're sculpting your debt, make sure that you don't go beyond 7 years. This is a 10-year tenor, so they maybe require 7 years. So for me now with this annuity payment, it is 5. So I have no issues and I put a check. So I put all the requirements. You might have some other requirements. So what I recommend you to do is to put all the requirements from your banks in front of you when you're doing your sculpting, because if one of them is triggered, you know that you need to just amend your sculpting in order to satisfy all the requirements by your lenders. Okay, so before we start our sculpting exercise, let's just refresh our memory on some of the definitions of the Dscr. So as you can see here, I put them here. So you know that by definition, we know that the debt service coverage ratios are basically the cash flow available by debt service divided by debt service. And debt service is nothing but principal plus interest. So when we just redo this equation, we're going to keep principal at the one side of the equation and bring everything on the other side of the equation. And that's what we're going to get as the equation, that the principal is equal to CFADS divided by Dscr minus interest. And in this case, we have a certain requirement by lenders for the Dscr. So we're going to have it as an input to this equation, and we're going to get the principal as an output. And that's what I am doing here. I'm taking the cash flow available for debt service, and I am just taking the interest as well. And as you can see here, this is just giving me this is exactly the same equation that we have here, which is going to give us the principal repayment given this profile for the debt service that I'm defining here. Okay, so just for the starting point, what I'm going to do, I'm going to switch this one to automatic sculpting. Okay, so now as you can see, if you look at the graph, you see that the Dscrs are 1.3, 1.3 all over, because that's what I defined here as my input. And the last one is going to just be very high, 3.03, because this one is just the one that is making sure that, you know, the debt is fully repaid. Okay, so in this one, debt is repaid. Of course, debt is fully repaid, and we have no issues with the ratios, but we have an issue with the LLCR, and we also have an issue with the tenor, because the tenor was 10 years, but we are not using the last year, right? As you can see here, this is the principal repayment, the one that is actually calculated in the model, and you see that these last 2 semesters we don't pay any principal, so we overpaid. You know, the 1.3 is kind of making this making us to repay the debt very fast, okay, so that we are just left with 1 semester which we don't have to pay it. So we are just wasting the tenor that we received from the lenders, right? However, we need to pay them according to the tenor that they have provided to us and pay interest and principal accordingly. So 1.3 is not, although it's the minimum requirement by the lenders, so I can do maybe higher. So I need to do a higher, I should start with a higher Dscr. Let's say, for example, I do 1.4 here, and then this one also, I'm gonna just let me fix this, and 1.4. So 1.4 all over. Okay, so that's going to be my target, and let's see what's going to happen to my Dscr. So as you can see, it is getting better. So I'm still left with 1 semester that I can just pay, so I can go higher for this one. Let's see if I do 1.5. If I do 1.5, you see that, you know, now it's fine. I am just paying over 9 years. The tenor is fine, but I have an issue with the minimum Dscr. Okay, so that's when I can come and use the goal seek function under Excel and do a goal seek. So I'm going to say, Excel, tell me what can I do if I want this check, which is the minimum Dscr check, to be 0. How can I do this? By modifying this target Dscr, okay? And this is going to tell us exactly what will be the Dscr. It is 1.49. So if you target a Dscr of 1.49 all over, you will see that, you know, that's going to work, okay? And it's going to give you, in terms of IRR, it's going to give you an IRR of 8.3. So that can be a good principal repayment profile that you want to suggest maybe to the lenders, or the lenders can come up with this repayment profile. Okay, so before we proceed with other sculpting options, let's record these 2 scenarios. So I'm just gonna maybe copy this switch here, and this is my scenario tab. I'm just gonna switch to my annuity, and I'm just going to copy it here as an annuity profile, payment profile. Okay, And then the second one is going to be the automatic sculpting, but then we're going to have automatic sculpting 1, 2, 3, 4. Okay, this one is the one that we just defined together. I'm just going to copy it as well. I'm going to call it sculpting 1, and I can put some definition for myself as well. 1 point, what was it? Do you remember? 1.49x across, right? So that's the one. As you can see here, you see the impact already on the equity IRR, that by sculpting the debt you can have, of course, you sorted out the issue with the minimum DSCR in this case, but in some cases, in some projects, you might not have a problem with the DSCR. You just want to optimize the sculpting in order to have like better ratios, better IRRs, better returns, and that's something that is interesting. So let's see if we can do even better. So this is fine. As you can see here, you have a DSCR of 1.49, which is above what the lenders require. Lenders require 1.3, and all of the requirements are met. But when I look at my weighted average loan life, I see that maybe I can do better. Maybe I can optimize this better by maybe what I call this called curved sculpting, is that you start with a higher DSCR and you go down gradually until you reach the minimum that the lenders require. This is what I call the curved sculpting. This is what Professor Edward Bodmer came up with as a name, and when we were working together on this topic. So let's see if we can do this. So what I'm going to do here, I'm going to say, let's say that this is an input from the model, the 1.3. So let's say, let's sculpt in such a way that we can start with like 1.49 and then gradually go down to 1.3. How is this going to look like? So you see, this is the ratio, and the minimum in this case is 1.32. So this is fine, but you see in terms of IRR, it's even worse. So I can do much better. Let's go crazy. Let's say I start with a very high DSCR of 2, okay? And as you can see here, if you choose 2, which is very high, what is going to happen is that you're going to pay less of principal in the beginning, and gradually you are going to increase it, you know, and the last one is going to be 19%, which is not going to work, you know, 19%, and you will not be able to repay your loan. So I'm just, you know, 2 is maybe too much. So let's do 1.7 and see if 1.7 works. So 1.7 is better. As you can see here, we are going from 1.7 to, but you know, the last one is 1.25. So it is still a bit problematic. So I'm going to just make my life easier, and I'm going to just do the goal seek. Of course, you can create a button and a macro to do all these things automatically. I'm just not going to do it today because I just wanted to show you. But you know, when you're doing it yourself, once you build this sheet within your model, you can also, of course, create the buttons for the goal seek. So what we're going to do is make this check to be 0, meaning that make sure that my minimum DSCR is 1.3. So make the check going to 0 by changing this starting DSCR, okay? So hopefully that's going to sort out. And as you can see here, it did, you know. So now we are starting with 1.68 and gradually we are going down to 1.36. So let's also save this one as another sculpting 2. Sculpting number 2. And you see that the IRR is now 18.7, okay, and everything else. Oh, but we have a little problem here with the, I didn't see this. We have a problem with the LLCR. So we need to do maybe another goal seek now. Goal seek this equal to 0 by changing the starting DSCR. Okay, so yes. So now this is going to be, okay, so because of this LLCR issue, we had to just amend the repayment profile. So basically that's going to be the one that we define as our second sculpted repayment profile, okay? Okay, perfect. So they did it. All right, so now when I look at this, I see I still think I can do better. I still think that I can optimize this thing better. Let's see if we can do something else. So what I'm going to do is that I'm going to say, I'm paying 2.444, all this here. What if I can even pay less here and then gradually start paying more? And as you pay less in the beginning, in terms of the IRR, it's going to give you a higher return in the IRR terms. Why? Because it's the time value of money, IRR and NPV, both of them. So if you have more payment upfront to your shareholders, it means that it's a better return to them. Okay, so let's see if we can just do this by, of course, by respecting all the requirements that the lenders are imposing. Let's see if we can just sculpt this resculpt this debt. Okay, so what I'm going to do is that I'm going to say I'm going to just define a ratio here in the middle. Let's say 9, the 9th repayment profile. So I want to go from 1.67 to maybe 1.6 and then gradually go to 1.3. Let's see if this is doable. You see, it's a bit aggressive. So yes, you're paying less here, but the last one is not working. Okay, so I need to find a solution. So what I'm going to do is that maybe I can just, you see, it's just a random play that is going to be a little bit painful. That's why I wanted to do it live with you, although it's a bit painful, but it's just an exercise that I do. And eventually, hopefully, if we do a session with Professor Edward Bodmer, you will see that, you can do all these things with a click by using the parallel model. But the way I do it right now is just this, kind of trial and error to come up with what I think is a more optimized repayment profile. Okay, so let's do my crazy way. Let's see this one, bring it to 0 by adjusting. This time, let's do the second level that I defined for the target. Let's see if it is possible or not. Maybe I was too aggressive in my first repayment. Let's see what happened. It's working. Okay, so it seems that this one, so I start with a very high and then gradually I go down. And then once I reach the 9th, then I just basically come to my 1.3, which the lenders, they require. Okay, that's not bad, but I think I can even do better. But let's save this one as an option. You see, the IRR is a little bit higher, so why not? Let's do sculpting number 3. Okay, and you see here it's just, decreasing these first payments. Okay, do you want to go further and try some other stuff as well? We can, but I think maybe that's going to be too long. So I'm going to just stop it here, but just to let you know that there is still room to improve this thing by just playing with these different, profiles and everything with these different parameters. We can further optimize this repayment profile, but I'm just going to leave it here. It was just to give you the idea of this, what is called the curved sculpting. And yeah, that's it for me. I hope you like this video. If you like it, please let me know in the comments. And because I want to continue on this topic, if I see that you guys are interested, I can just maybe further, come up with a more complicated model and gradually show you a point where we can no longer do this the way we do it, and we need to just come up with some other ways of sculpting our debt. All right, so that's it for me, and I hope to see you in my next video. Thank you and bye.